let me give you example first. So the example, so here I modify it. Okay, so now you use this newer version to replace the previous version, the version in our session 1, the first session. Case 2. So here I add case 2. All right. Sample question. I found a relatively simple sample question. So if you look at the coefficients, it is simpler, even simpler than our case 1 question. But when you do the work, relatively more work. So I do not want to say very hard. But relatively a little more work. Comparing with other questions in our final. So this one, you need to do a little more work. But the good thing is you have a chance to leave it in one of the 3 second chance questions, right? So if our regular test time, 2 hours, if you feel too tight, because for this one, I think at least you need 20 minutes, 20 to 30 minutes, at least. If that much time too tight for you when you do it in the final, so you can leave it as the second chance question. All right, so here, let me show you the detailed steps. All right. First, I want to review the theory a little bit. So the second chance. So let's review the theory. The Frobenius method. So the Frobenius method. And we want to solve this equation. Okay? So then the solution form like this. Okay? But first we need to determine the R, appropriate R. All right. So there are 3 cases. All right. Then, so here, I just put the standard form here. Then, how to see that 3 cases? First, let's compare the B function and the C function. We treat this as the standard form. Here, let's convert it to the standard form. We divide it by that x. So we get a y double prime minus 1 over x y prime plus, let me write, 1 plus x over x squared. Y equals 0. Now you can see b of x, negative 1, right? Because you need to consider the sign, negative 1. And the c of x, this 1 plus x, okay? Then, based on that, first we need to determine the appropriate R number. Then, so when we write B function, C function in that way, so we need to use the B0 and the C0. So in this question, B0 is negative 1. C0 is 1. This C0, 1. Okay, Then, we have a special equation we called indicial equation, right? So let's look at the indicial equation. This is the definition of the indicial equation. So using this equation, we can find the solution, 2 possible solutions, R1, R2, solving this quadratic equation. So here, if I write R squared minus R minus another R, B0, negative 1, then plus 1 equals 0. Now you can see the solution is double root r equals 0, equals 1, it's a double root. Okay? Double root corresponds to case 2. Okay? That's the case 2. Yeah. So here, this double root. Yeah. For the case 2, let me take the case 2 result. So first we have the double root. Yeah, case 2. Case 2. Yeah. So here R has this form. Yeah, because we need to see it has a double root, then we can use this formula, right? Because before you look at the quadratic equation, you do not know it has a double root. If you do not know it has a double root, how can you use this formula? Yeah, yeah. But this one, we see it's a double root. Yeah, so we need to use this initial equation to see it. After that, then your y1, y2 has the y1 still as our old form, right? But your y2, you need to add a special term. Then y2. Yeah. Yeah. So the structure of the similar. Yeah. So here is the structure. Yeah. Also here, a1x. See, capital A0 is 0. Yeah. Yeah. Inside the parenthesis. Yeah. Yeah. Starting from A1. Yeah. So that's the appropriate form of the y2 function. That's a special one. Yeah. So but you need to find y1 first. Yeah. Because y1 you need to use it here. Right. So when you need to determine capital A coefficients, you need to use your y1 solution. Yeah. It looks pretty complicated, right? It looks pretty complicated. Yeah. But the good thing is this question, I give you the simplest possible coefficient numbers, the simplest possible. Yeah. In our final question, I will change slightly. Okay. Yeah. I try to make it as simple as possible, but I will change it slightly. Yeah. Yeah. Then let's use, because the reason I want to give you this case 2. Case 2, I feel it is easier than case 3. So that's why I do not select case 3. Case 3 even harder than case 2. Yeah. So but I want you to experience this case 2. Yeah. So that's for that reason I want to give you this example in the final. Yeah. Not too much harder, yeah. Reasonably harder, yeah. But the experience I think is good for you. Yeah. All right. So let me now I will do the solution right here. Okay, step by step. Yeah, not very messy. Okay, I just want to show you we can handle the calculation like this. Yeah. All right. The first step, calculate y1. Yeah, that's we did in our case 1 example. Yeah. Actually, it is easier than our case 1. Why? Because r is 1, right? Our case 1 example, our r to 1/2 and 3/4. Yeah. So that calculation is harder than r equals 1. Yeah. So the y1 easier. Yeah. Then y2, although you add an extra term, but not too much harder. Yeah. Not too much harder. All right. Yeah. Now let me show you the calculation. Let's do it here. All right. For the y1, first, let's write the y1 form first. Yeah. Before we take the derivative. So y1, we know it is x to the r, that's 1, just x. Yeah. A0 plus A1x plus A2 x squared. Yeah, let me write to A3 term. Yeah, so that should be, good enough. Yeah. Then, before we take derivative, multiply through, yeah, because this way it's easier to take derivative. Yeah. Cube to the 4th. Okay. Yeah. All right. So y1 prime. Yeah. So I think these steps pretty easy. So you can handle easily. 2a1x 3a2x squared 4a3x cubed. Yeah, enough, right? y1 double prime 2a1 plus 6a2 plus 12a3. Yeah. Okay. Yeah. Then, yeah. Oh, before we. Yeah. So although, this equation. Yeah. But when we do it, we want to remove the denominator, right? So we will convert it. Yeah. So we will rewrite the form, more convenient form. So here the standard form may not be convenient. So the convenient form, we want to eliminate all the denominators. Yeah, so that's more convenient. So we want to use this form, y squared, x squared double y double prime minus x y prime plus. You can write in this order. Right. Then we calculate term by term. Okay? Yeah. Be patient. Yeah. So we need to first, in our mind, we need to, make sure when you work on this question, we are very patient. Yeah. All right. Y double prime multiply x squared. So x squared y1 double prime 2a1 x squared plus 6a2 x cubed plus 12a3 x to the 4th. Yeah. So that should be enough. Yeah. All right. Then negative second term, we keep the sign negative x y1 prime. Yeah. So use this one. So negative a0 x minus 2a1 x squared minus 3a2 x cubed minus 4a3 x to the 4th. Yeah. All right. Then the third one, x plus 1 times y1. Yeah. First, let's do x times y1. Okay. X times y1, use y1. Yeah. Yeah. So we write these two terms separately. Yeah. In two lines. Yeah. In order to make the calculation easier. So x a0 x squared plus a1 x cubed a2 x to the 4th. Yeah. Yeah. Because the highest term, we just get to x to the 4th. Yeah. All right. All right. Then just copy the y1 a1x squared a2x cubed a3x to the fourth. All right, now adding together. All right, yeah. Adding together, right. Yeah, so first, this term cancel out, right? Yeah, because we expect that based on the initial equation. Initial equation is used to cancel out the lowest degree terms. Yeah. So cancellation. Then square, x squared term, yeah, 2a1 cancel out, right? Yeah. So square term, only these two left. So we have a0 plus a1x squared. All right. Cube term 6a2 minus 3a2 and a1, but a2 here, right? Yeah. 6 minus 3 plus 1. Yeah. So 4, right? 4a2 and a1. 1a1. So a1 plus 4a2 x cubed. Then last term, yeah, x to the fourth, last term we need in our calculation. Okay. 12a3 minus 4a3, 8a3. Okay, 8a3, but you need to add one more. So 9a3 plus 1a2. Okay, yeah. So a2 plus 9a3 times x to the fourth. Yeah. So this equals 0. Okay, equals 0. Then we can find, yeah, because a0 we use it as parameter. Okay, a0 we use it as parameter. So a1 equals negative a0. a2 equals negative 1/4 times a1, but if we represent in a0, so positive 1/4 a0. Yeah. a3 equals negative 1/9 a2. We write it in terms of a0, so you have negative 1/36 a0. Okay, yeah, that's enough. Okay. Then we need to write y1 function. Okay. Let me write y1 function here. When we write the y1 solution, we can use any parameter a0, right? a0 we treat it as a constant. So any constant we can use in our y1. Yeah. But when we write y1, can we just make a0 equal to 1? Yeah. Because later we will add some free constants. Yeah. Add some, other flexible constant. Yeah. So this place we want to make y1 as simple as possible. Yeah. So when we write y1, we choose a0, 1. Yeah. To make it easy, because our goal will find a basis, right? Find a basis. One special fixed y1 and another special fixed y2. Then, when we use these two basis functions to write the general solution, then we use C1, C2, right? Yeah. So for that consideration, yeah, so we can choose a0 equals 1 to write y1 solution. Yeah. y1 solution, y1 of x equals x times 1 minus 1/4 x. Yeah. Sorry, not 1. Minus, yeah, because the first is a negative. So minus x plus 1/4 x squared minus 1/36 x cubed plus. Yeah, that's A1. Okay? Yeah. So we need to use this expression, yeah, when we find y2. So now we complete y1 part. Yeah. Next, y2 part. Yeah. Yeah, let me see. Yeah. Yeah. So I hope it won't take too much time. Yeah. So I look at my watch, control the time. Let me look at how long I need. Can I find a y2 in 10 minutes? Yeah. I try to see if I can find it in 10 minutes, y2. Then it's not too bad, right? Yeah, because here you can see I do the talking, I do the explanation. Yeah. So actually, people can do faster. If you do not do the talking, just keep working, writing pretty fast, yeah, you can save a few more minutes. Yeah. All right, so let's continue the y2 part. y2 part, remember our y2 has this form. Based on the case 2, y1 times natural log of x plus x times capital A1x, capital A2 x squared, capital A3 x cubed. Okay? Yeah, so after we determine these capital A coefficients, then we complete y2 solution. Yeah. All right. First, let's take the derivative. Yeah. Derivative, two parts derivative. Yeah. Yeah. Hope it's not too complicated. Yeah. So y2 prime of x equals y1 prime of x times natural log, then plus natural log derivative, yeah, so that's y1 over x. Yeah, not too bad. Yeah. Then inside, multiply through, right? The version, multiply through. So 2a1x plus 3a2 x squared plus 4 capital A3 cubed. Yeah, so not too bad. Yeah. y2 double prime. Yeah, this one a little harder. Yeah, but hopefully not too much harder. Yeah. So y2 double prime of x. Product rule, so y1 double prime times natural log of x plus y1 prime over x. Okay? Yeah. Then plus quotient rule. Yeah. For this term, we need to use the quotient rule. X squared. Okay? y1 prime of x times x minus x derivative, that's 1, so minus y1 of x. Quotient rule, okay? Yeah. But the first term in this fraction, you can see the same as this term, so we can combine, okay? So not too bad, not too bad. Yeah. All right, then inside the parenthesis, 2a1 plus 6 capital A2 x plus 12 capital A3 x squared. Okay? All right. Yeah, let me write one more step before I do the multiplication. Yeah. Yeah, so simplification, you get 2y1 x minus y1 x squared plus a1 plus. All right, yeah. So ready for the all right. Okay, yeah. And let me write the convenient form again, okay? Because we need to calculate convenient form. X squared y double prime minus x plus 1y. That's the convenient form, okay, when we do the work. So let's calculate x squared y2 double prime of x. Okay, here I do it together with you, just another purpose doing this way. I want to help you overcome the, psychologically overcome the difficulty impression. Otherwise, some students may feel too hard, then give up. So don't give up, okay? So you do this kind of basic calculation. Just be patient, yeah. Do not give up, yeah. All right. Then multiply this version, okay, yeah. So x squared double prime natural log. Then denominator is gone, right? When we multiply x squared. So 2x y1. Yeah. So denominator is gone. That's good. y1 of x. Okay. Yeah, pretty nice. Yeah. Then 2 capital A x squared plus 6 capital 2 plus 12 capital A3 fourth. All right, yeah, yeah. Then negative x y2 prime of x. Yeah. So use this line, okay? Yeah, yeah. So minus, we need to keep the minus sign. Minus x y1 prime natural log of x minus y1 of x. See? Yeah? So he can combine, okay, these two. Then the parenthesis, inside parenthesis, yeah, the negative. Yeah, let's put a negative sign out. Okay. Inside parenthesis, 2 capital A1 x squared plus 3 capital A2 x cubed plus 4 capital A3 x to the fourth. You can see, these two parentheses, they can be combined, right? Oh, yeah, subtraction. Even better. All right, so last part, plus x plus 1 y2. Yeah. Yeah. So using this x y1 natural log plus inside A1 x cubed plus A2 x to the fourth. Fourth, that's enough, right? Yeah, because we just do it at a fourth. Yeah. Then plus y1 A1 x squared A2 x cubed A3 x to the fourth. All right. Yeah. Now addition. Yeah, so a little messy. Yeah, but first, when we add up this part, after we take the natural log, because they have a common factor, natural log, take it out. Is it the 0? Because x1 is the solution. When we plug in x1 into the original equation, it must be 0. Okay? Then that means this whole block is gone. Okay? Whole block is gone. All right. Then this part, other than the capital A terms. Yeah. So capital A terms. So other than capital A terms, we have so here I do not have space. Yeah. So yeah, I do not have space to write. Yeah. Yeah. Okay. So 2x y1 prime of x minus 2 y1x. This place we need to use the y1 solution. Okay? Yeah. Then the capital A terms. Capital A terms minus gone. Okay? Yeah. So that's that. But you have a capital A1 x squared left. Yeah. Yeah, so let me use this place, right? So x squared term, A1 x squared. Yeah. X cubed term. So 6 minus 3, 3x2, 3a2, 3a2 plus, right? A2. So 4a2, A1, yeah, so here you see, plus A1 plus 4a2 x cubed. Okay, yeah. Then, last term, 12 minus 4, 8. 8 plus 1, also 9. So A2, yeah, here you can see the format similar to the y1 solution. Plus 9a3 fourth. Okay, all right. Yeah, so here, yeah. But we need to clean up. When we go to the next screen, yeah, we need to do some cleanup work. Yeah. All right. So let me just quickly copy. So what do we have here? Yeah. And we move to the next screen. Yeah. So let me write on my paper 2x times y1 prime of x minus 2 times y1 of x. Okay. Then inside the parenthesis, we have A1 x squared plus parenthesis A1 plus 4A2 times x cubed plus A2 times 9A3 times x to the fourth. All right, so let's carry over to the next slide. All right. Yeah, so this slide, I think we can find the capital A, all the capital A coefficients. Yeah. All right, so this slide, yeah. But first I need to, write the cleanup thing. Yeah, let me look at the time. Yeah, I want to see the control. Oh, 14 minutes. Yeah, yeah, but I use the 14 minutes. Yeah, because I'm doing too slow. Yeah, my space too limited. Yeah, so that, all right. So y1 of x equals x minus x squared plus 1/4 x cubed minus 1/36 x to the 4th. This is y1, okay? And we also have this 2x y1 prime of x minus 2 y1 of x plus a1 x squared plus a1 plus 4 a2 plus 9 capital A3 x to the 4th. All right, equals 0. All right. Yeah, so the last step, all right, calculation. 2x y1 prime of x. Yeah, so here we need to calculate one more step. 2x times 1 minus 2x plus 3/4 x squared minus 1/36, 4, yeah, 4, that's 9, okay? 9, 1/9 x cubed, yeah. All right, yeah, so that's this. 2x minus 4x squared plus 3 seconds x cubed minus 2/9 x to the 4th. All right, this term. Okay. Minus 2y1 minus 2x plus 2x squared minus 1/2 times x cubed plus 1/18 x to the 4th. Okay, all right, so then also add up that big bracket part, okay? So I do not copy that big bracket. Adding together. All right, yeah. 2x, negative 2x cancel out, okay? Then let's compare the square term, yeah. Minus 2, so a1 minus 2 x squared plus, okay, all right. X cubed, yeah, so that's 1, positive 1, right? Positive 1 plus that number, a1 plus 4a2 x cubed, then the last term. This one, adding together, negative, yeah, 3/18, that's 1/6, okay? Negative 1/6 plus a2 plus 9a3 x to the 4th. 0, okay? All right. So capital A1 equals 2, okay? 2, 3, so capital A2 equals negative 3/4. Okay, all right. Then, so 1 minus 3/4 plus 9a equals 0. Yeah. So we find, yeah, let me just do one more step. Yeah, because I want to really complete it, although it's not necessary, right? So negative, let's use 12. 12, 2 plus 9. 2 plus 9, 11, right? Yeah. 11, okay? Negative 11/12. Yeah, so plus 9a3 equals 0. So a3 equals 11/108. Yeah, right? So then we can write y2, right? Yeah. So y2, you can write it out. Okay. Yeah. So y1, we do not need to expand it. Okay, we keep this y1. Okay. Yeah. So then capital A1. Yeah. So yeah, because we have that x. Yeah. I remember. Yeah. So let's use this way, right? Yeah. Let's use this way. All right. So 2x squared, yeah, a12 minus 3, negative 1, okay, minus x cubed plus a2 this one, plus 9a3. 9a3, 9 times 12, 11/12, as I remember. 9, 11/12, minus 3/4, so 9, 2, 1/6 plus 1/6 x to the 4th. Okay, so yeah. Then we complete the whole solution, the basis, two basis functions, y1, y2, you know, in this way. Yeah. So that's the time we need. Yeah. So here I use approximately 20 minutes. Here you can see I use a very slow pace. Yeah. Not in a rush. Okay. Yeah. If I do in a very quiet environment and I do not say anything, yeah, I think I can save at least 5 minutes. Yeah. 10 something minutes. Yeah. I just measure how much time I need to complete to find a solution. So I feel I can do it in 15 minutes. Yeah. For a question like this. Yeah. Just let you know, do not be scared by this question. Okay? So you can handle. Be patient, you can handle. Yeah. All right, so this question, I will change these two terms slightly in our final. Okay? Yeah, these two terms slightly in the final. But the number still, I want to make it as simple as possible. Not very messy. Okay? Yeah. Similar to this one. Yeah. Hopefully it's not too bad. Yeah. I just want to give you some experience. Yeah. All right, so that's this question. Then next, I want to give you the remaining 5 sample questions. Yeah, but so here, let's do not take a break. I think I just need 10 more minutes. I can go through the remaining 5 questions. Then, so we're done. Yeah. All right. Yeah, we don't need this. Yeah, last 5 questions. Yeah. Number 6, possibles identity. Okay, I mentioned that. Yeah. So this is from our homework assignment number 4B. Yeah, 4B. So the question like this: you need to, calculate the Fourier series first. After that, you apply the possible identity. Yeah. So that should be pretty easy. Yeah. All right. So then the next one, I want you to calculate another about Fourier cosine sine integral. Yeah, but this question, because in our notes and the textbook, we have the formulas. We just find the formula, then we, choose appropriate numbers. We can find this one. But in the final, I want to choose an example for which we do not have existing formulas. Okay, so first you need to calculate that Fourier cosine sine integral. Yeah, just like our examples, yeah, in our notes and the textbook. The similar way, we need to apply the Fourier cosine sine integral to do the calculation. Yeah. After the calculation, then you can get some identity like this. Okay. Yeah. So that's the small difference. Yeah. Otherwise, too easy, right? So if I give you the question like this in the final, then it's too easy because you can find appropriate formula, then plug in some numbers, then you're done. Too easy. So I want to make it, you need to do some reasonable amount of work. Yeah. So calculate the Fourier cosine or sine integrals first. Yeah. Then you can, derive that. So I will give you the, this identity. You need to prove it. Okay. Yeah. So that's the question number 7. Yeah. Number 8. Minimum square error. So another question in our assignment. Yeah. Yeah. So here I ask you to use this many terms. Yeah. So n equals 5, the highest degree term 5. Yeah. To approximate some function. Yeah. So so we have a theorem, right? So minimum error. So that theorem. Yeah. So then you get a conclusion. Yeah. Also pretty easy. Yeah. This question, I think, just some relatively simple calculation. Yeah. Also pretty easy. Yeah. So here, after you see all these 10 questions, I hope all our students, so you can do it without feel too hard. Yeah. Without feeling too hard. Yeah.
I have a question on this one.
Yeah. What question?
So do we have to apply the theorem straightforward? Because when we find
No.
the trigonometric polynomial, if we use the Fourier
Yeah.
then isn't Fourier automatically assuming that it's the minimum?
Yes. Yes. Yeah. That's the theorem. That's the minimum square. You just find the coefficients. Then you make the conclusion. Yeah. Because the theorem tells us that. Yeah. The theorem tells us that. Yeah. Yeah. So you do not need to prove this is really the minimum. Okay? Yeah. 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 I just want to, the purpose want to make you aware of it. Yeah. So based on the theorem, yeah, that's the minimum. Yeah. Yeah, because if some student does not know the theorem, then it's hard. Yeah. How do you show it is the minimum? Yeah. Yeah. So then nothing. So you can, after your calculation, so then you make your conclusion. Yeah. All right. Yeah. So you can see most of our questions not too hard. Okay. Yeah. Yeah. So I try to, because the final is very important. So I don't want any student, do very bad in the final. Okay. Yeah. So that's critical. Yeah. All right. All right. Then question number 9. Yeah. So this question you may need to do some calculation. Yeah. A little more work than many of other questions. Yeah. But still not too bad. Yeah. Because you can also put it in one of the 3 second chance questions if you feel you don't have enough time. But so then, Fourier series expansion, right? So then, solve it based on our example. Yeah. I mean, in your homework assignment, you did it. So it's not new for you. Okay. Yeah. Just do a similar one. Yeah. I want to check so if you can do it smoothly, yeah, in the final. Yeah. So that's number 9. The last one, actually the last one, yeah. Also, I want to, let you practice this property, derivative property. Okay, calculate Fourier transform. Yeah, apply the derivative property. Yeah, yeah. So that's all our 10 questions. Yeah. So I hope all 12 students. Now I just treat, so we have 12 students. Yeah, because two of the 12 so never respond. Yeah, so those 2, one of the 2 already dropped it. Yeah, the other 2 didn't drop but never do anything. Yeah, yeah. So let me just look at those 12 students. I hope those 12 students, you at least you can do most of the work. Yeah. So yeah, because all these questions very basic. Yeah, very basic. Yeah. So and you just study all the sample questions. Yeah. So when you do your preparation, just make sure you understand all the details of the sample questions. Yeah. So then in the final 2 hours, you can calm down. Yeah. Yeah, because 3 questions you can put in the second chance. So you can calm down. Okay. Yeah. Solve one by one. Yeah. So then, yeah. Yeah. If you can complete, so that's, yeah, I feel, the top 3 or 4 students, actually you can complete in 2 hours. Then when you get home, you don't need to do anything, right? Yeah, because even the question we just solved, that relatively long, tedious work, that question we can do in about 15 minutes. Okay. Many other questions you just need 5 to 10 minutes. Okay. Yeah. So then, I believe at least 3 or 4 students, you just complete all 10 questions within 2 hours. Yeah. Then you can forget about it. Yeah. But some of the students, then I give you a second chance for 3 questions. Yeah. So then hopefully, all 12 students, I hope, the bottom line, all 12 students pass this class. Okay, all 12 students pass this class. Yeah, make sure that. Yeah, yeah. But those 12 students, one thing you need to do, you need to make sure you submit homework assignment number 3 and number 4. Okay, otherwise, if you miss one, then it's hard to pass. Okay, yeah. So I will urge. So next on Tuesday, our final test time, I will urge, if one student has not submit, I will make sure that student submit it. Yeah. All right, so that's how much I want to say in our review. Yeah, so then I will let you go. So you, after I finish grading, so then I will make test questions. Yeah. So we will see on Tuesday, yeah, our regular class time, Tuesday, but different classroom. All right, so that's all we have for this semester before the final.